Hey there. Can you hear me all right?
Yep, can you hear me?
Yeah, perfect. Hey. So awesome. Let me just get everybody in the room and then we can get going pretty soon. Just real quick.
Sounds good.
Okay. Righty. So welcome everybody to this meetup. It's been a while. I'm your host, BJ, and I run the JavaScript LA meetup group. Let me go ahead and just share my screen real quick so everybody can see. And I'm just going to pull this over here. So let's do it one more time. Share desktop one. Perfect. All right. So basically, yeah, this is a group that meets up pretty much like once a month. This is our first meetup of the year. And so I want to just thank you, Ben, for, coming by and, talking to us about iOS and SwiftUI. Normally we have meetups on JavaScript, but we've started moving towards a new brand called HackBuddy. And so some of you are aware of that. And essentially what we're doing now is we're doing more software engineering talks. And so that in that way, we're trying to like expand beyond just normal JavaScript, give other developers a chance to kind of explain their stacks, because at the end of the day, really it's about sharing knowledge. And I think a lot of the stuff that you learn in one stack can be applied to another stack and so on. So just, if you have questions about this group, I'm always available. You can reach out to me via javascriptla.net. You can go to the contact us part and send an email to info@javascriptla.net. A lot of people also ask about where do the videos get posted afterwards. And so that's on this website, youtube.com/hackbuddy, and it's org. So all of the videos that we have usually get posted to YouTube. And so this video as well will get posted to YouTube. If you have any questions, again, about videos or the group or when we have meetups, I'm your point of contact person. You can also connect with me on LinkedIn. I know a lot of people like that. And so my LinkedIn is just linkedin.com/in/vjextreme. And I'll go ahead and put that in the chat. Oh, I see like you guys are saying my audio sounds a little weak. Can you hear me all right now? Is anybody not able to hear me? Okay. All right, so basically, just one more time, the shortened version. Essentially, please feel free to connect with me on LinkedIn. Our meetups are monthly. And if you want to know more about our meetups, most of the information is on our website, javascriptla.net, and all the videos get posted to youtube.com/hackbuddyorg. Ben, would you like to test your screen and all that real quick with us?
Sure thing. Let me go ahead and take over.
Yeah, sure.
Oh, it looks like I might need host permissions for screen sharing.
Yeah, I'm about to give them to you right now.
Perfect.
Okay. All righty.
All right, some good host permissions. Okay. Share over.
Oh, I forgot it all.
All right, can you see my screen okay?
Yes, definitely.
Perfect. Cool. So take it away here.
Yeah, please do. Without further ado, let's give it a hand for Ben. Thank you for coming again, and let's just jump into it.
Sure thing. All righty, so we'll go ahead and get started here. My name is Ben Stone. I think there's a few other people who have been here before, work as a day job at Codecademy. So I've been there for about a year or so. I'm not here on any kind of official capacity, but I think there's a bunch of Codecademy people who stop by this meetup every so often. So I've been at Codecademy for the last year or so, before I was at Codecademy, I had a variety of different jobs, starting off as a middle school math teacher. I then worked at a nonprofit coding bootcamp where I learned iOS development and then ended up teaching some iOS development there as well. And then I went to work as an iOS developer at a point of sale company called Shopkeep, which was recently acquired by Lightspeed. So some iOS development in the point of sale space, and that before ending up where I am now at Codecademy. So I've worked there for about a year, and I've been putting together some of our content around iOS development, and it's been a lot of fun. So what we're going to be doing in this session today is starting with a blank app here. So that's what we see up here. If you want to follow along and have Xcode, just open up a new project, make sure it's set to SwiftUI, and you'll be ready to go. If you just like to follow along and see kind of what we're doing and get a feel for this technology, that's great too. And then you can check out the video that's going to be posted up on the channel later on. As I'm going, if you have questions, you can feel free to put things in the chat, and I am more than happy to stop and talk about anything that seems particularly interesting. I have a rough idea of what I'm going to be doing. I've sketched this app out before, but I can certainly ad lib based on what people are interested in seeing as well. I'll be doing this for, depending on kind of what kind of questions we get, somewhere between 45 and an hour, and then we'll be having a longer Q&A section afterwards. So if you do have any specific questions, you can feel free to ask whatever in chat, and then we will have a dedicated section at the end to go over them. And if there are any specific questions, do feel free to put them in chat. And then just make sure that you have yourself muted if you're not going to be talking here. Okay, great. So there's been one talk on SwiftUI before, I think, from this forum, but if it's a totally new technology for you, that's great. This is SwiftUI, is what we're looking at right here. So this is an iPhone. This is Apple's framework for developing iOS applications. It is substantially easier than the framework that was used before, which is UIKit. That was a very verbose framework. It was a very powerful one, but it could take a really long time in order to actually accomplish what you're trying to do. So I'm going to go ahead and start by previewing just a little bit of how some of the kind of mechanics works here, how to actually use Xcode and get into it. And then we're going to start to build a miniature quiz app. So we'll have a question up here. We'll have some possible answers. You'll click on an answer. It'll tell if you're right or wrong. You'll click to get to the next question. And then you can go ahead and then see what kind of the results look like. Okay, so let me expand that out. Great. Okay, so this is Xcode. What you see right here is what's called the canvas. So the canvas describes a little iPhone. And if you're used to coding in React or in JavaScript stuff, it's pretty similar in that as you make changes, you can see them live previewed in the canvas here. This definitely did not used to be the case in iOS development, and it is a pleasure that this is a thing right now. So you get to see content changing here. You can change it in this little panel here. And there's all kinds of modifiers that you can be applying to. You can change the font and get to see it reflect bigger once it loads. Sometimes it can be slow. There we go. And then content can update this way. You'll notice as we make changes in this panel on the right, it automatically adds in what exactly we're changing and how to generate that. Well, you can go ahead, yeah, all the time. You can go ahead and work mainly from using this panel. It's a little bit easier most of the time just to go ahead and work with code. So I'll be doing that for the most part. Okay, so we want to put a quiz app together. Let's start off with maybe a simple question. So maybe not so simple question, but a fun one that I like to use. So you may not know, but the term computer bug wasn't actually just a term from nowhere. It actually used to refer to a specific bug. So my starting question is, what was the first computer bug? Post in chat if you know, because there was a real bug that was actually caused problems in really old computers. Yeah, I see Josh H knows. Yeah, it was a moth there, but we'll have some distractors in. That's a fun one. Yeah, or Y2K. That one was a bit later. Okay, so we have this. We can notice that the text changed again. Maybe I want that to be centered, so I can go ahead and just add that alignment, and we can see that it just adds that in for us. And then we want to have our possible answers. So what I'm going to do is I'm going to say, oh, maybe we know that moth is the correct answer. What if we just put this in here? Well, something weird is going to happen. We're actually going to have another iPhone appear below. This is because when you're working inside of SwiftUI, you can actually only have one view that's returned from this body. So if you want to have multiple things layered on top of each other, you need to embed those in some kind of container. The easiest one to work with is probably a vertical stack. And if you have a vertical stack container, it means that these views will be stacked up on top of each other. It's kind of overlapping a little bit here, so we can make sure to add that padding back in. And then we can see our options showing up here. Now, we might have multiple options because we want to have this be a quiz. So let's make another little nested V stack. I'm going to do this little trick to make my highlighting or my formatting, which is Control-I. You'll use that a lot in Xcode development. And then I can add any number of distractors or other answers I want here. So maybe we've got a moth, maybe we've got an ant, maybe a fly, maybe a beetle, some other distractors that we can be putting in. And this seems like it's kind of a tedious process here. So we're having to kind of write out these. If we have any custom formatting, we're going to have to apply it to each of these texts. And while that will work, it's a little inelegant. So it'd be nice if there was a more convenient way to go ahead about this process. And our preview is being slow because that happens sometimes in SwiftUI development. Okay, so instead of going and just having each of these listed out, a better approach would be to have a neat Swift structure that's called a for each that can go ahead and stack each of those separately. I'll go give this another shot, clean and build again. Okay, so what we'll do is we'll store maybe our possible answers in some kind of array up here. We have an ant, a moth, fly, and a beetle. So that instead of having each of these hard-coded, we can now refer to this array here. All right, let's see if this woke up. Okay, so now instead of having these one by one, we can use this structure called a for each, which is going to let us iterate over each of these possible answers. So we can go over each of the possible answers, here over each of the indices, grab the index, and then just get the element that we're interested in from the array. So now we can grab the possible answers at the particular index we're looking at and apply any kind of formatting that we're looking to do here. So this here is how Swift uses its higher ordered functions. So I think JavaScript has a for each that's somewhat similar. And then this should render the preview we want. I'm going to do something that you might get used to if you're working in Xcode, which is I'm going to close and reopen it to wake up the preview. It is generally quite cooperative, though sometimes it can be less cooperative. Okay. So we've got our possible answers. We've got an array rendered here, and now we can see them rendered correctly. So like many things, turning it off and on again, a good solution. Now, the formatting doesn't really look like much of a quiz question yet. It'd be nice if there's a little bit of space here. So what we're going to do is we're going to grab in from one of these views. And this is a neat way if you're new to the environment to kind of poke around and get to see what's an option without just typing things out. And we're going to jump in a spacer. And that's a way of adding in a little bit of room between things. So putting in a spacer, we're going to end up pushing some of the text to the top and some to the bottom. And then we can put in another spacer to even it out. So spacer is a special view that just takes as much space up as it can. There's a lot of magic on how SwiftUI chooses to render these things. Usually it's what you want. You have a lot of flexibility if it isn't. Okay, then for each of these texts, we're going to want to add a little bit of formatting. So each of these texts is going to have some padding like we already gave it. We probably want to give it some kind of border so it stands out a little bit more. So maybe we can make it a border that's blue that has a width of 4. And then that'll apply a border to each of these. We can see that pop up. And that's a little better. It's a little weird though that they're all different sizes. So the way that we're going to fix that is we're going to tell SwiftUI here that this vertical stack that arranges everything should be a fixed size in the horizontal direction. but take up as much space as it needs in the vertical direction. And then tell each of these individual texts that the frame that they should occupy has a, we got to fight through some of these initializers, has a frame with a max width of infinity. So by setting that up, we're telling it you can take up as much space, you should take up as much space as you can horizontally. Everything should be at the same size, and then each individual thing should take up as much size as the thing that takes up the most size takes. So that way it looks a little bit more uniform. Okay, so now we've got these, we've got kind of a quiz set up, but these are just texts, right? So we're not actually doing anything with any of these here. So we want these to be dynamic or interactive. So how can we add some dynamism there? Well, what we're going to want to do first probably is structure this a little bit more sensibly. So we've got these possible answers here. Maybe we want to have this abstracted out as well, so we can take that. So we'll take our question. What is the first computer bug? And now we can just refer to the question. We're going to keep doing a lot of refactoring over the course of this. So we're going to start off and kind of gradually move backwards in scope as we start to be kind of pulling things out and seeing more of our needs here. Okay, so we want to add some interactivity. Well, the first thing that we're probably going to want to do is make this a button instead of a text. So buttons are, unsurprisingly, things you can click on. So right now we can't, clicking on it just doesn't produce anything. So we're going to want to make this a button. And in SwiftUI, you can have this here, which is using called trailing closure syntax. It's just a set of imperative commands that happen once you click on the button. Now, it would be great to have some kind of storage and say, once we've clicked on it, then we know that, what's been clicked on, and maybe we can do something with that information. So let's go ahead and make some selected index here. So this is going to be the index that the user selected on. We can use a neat Swift type here, which is an optional integer, which is in some languages called a maybe. It's a type that either has no value at all, the absence of the value, it's nil, or it has a real value. Ours is going to start off as nil to reflect that there is no selected index, but eventually they're going to select something. Okay, and so what are we going to do with that? Well, once there is an index that's selected, it'd be great if we could go and highlight the button appropriately so that if they click on moth and it's correct, then this gets highlighted green. And if they click on something else, then it gets highlighted as red. So let's go ahead and figure out how to make a little bit of that logic work. So what we want to do is add in a background color that is either clear or is kind of the right red or green, depending on what happens. So we're going to make a little method at the bottom here that'll tell us what color things should be highlighted. So we'll call this color for button at index. And this is going to go ahead and tell us what should the background color of each button be. Now, if there is no selected index, so if the selected index is nil, then we say, well, it's still clear then because they haven't made any selection. As this is very reactive style programming, right? So we're all depending on what the selected index looks like for the state of our application. In Swift, the way of getting to that in a very Swifty manner is called, you can use optional binding here with the guardlet. So I can say that the selected index is the selected index. And we want to make sure that it's something that they've actually, that it's the one that they clicked on here. So this makes sure that they have selected an index. And we only want to color in the one that they've actually clicked on. So make sure that the index is a selected index and that the index we're looking to color is in fact the one that they have selected. If neither of those are true, then we want to go ahead and return a clear background color. So this is here, the Swift is a compiled language, which means that at the end of each code path, you have to return whatever your function is returning here. So that's what happens if we have, if we have in this state right now, when we haven't clicked on anything. Once we've clicked on something, if the thing that we've clicked on, if that selected index is in fact equal to the correct index, which I guess we have to store somewhere, which we'll do here for now. So maybe call that like a correct index. And that's index 1, because a moth is that first bug that we found here. So if that selected index is equal to the correct index, then we want to return a color of green. And if it's not, then we want to return a color of red. Yeah, and we can share out the code for all this at the end. Okay, so that's going to be our code here that determines the color for the button. Then our the next thing to do is to actually hook that up so that we're using the color correctly. So let's go back up here where we're setting each of our buttons, and then we'll set that the background color for the button. We'll do that right here. That the background for the button. Background, there we go, should be the color at whatever index we're currently on. Okay, great. So that's all hooked up. Always good to make sure that things are building. So we check, we're still building. And updating again. Yep. Let's see. Is it actually unhappy somewhere? Nope, it's good. All right, so then we'll go ahead and when we click on the button, we actually want to change the selected index to be the index that they selected. So we'll go ahead and try to set that. Selected index is equal to index. And now when we build, we should get an error. And that's because Swift is this is a kind of a reactive programming paradigm, which means that we're based on state. And you are not allowed to change things unless you're making it very clear to the SwiftUI compiler that this is an intentional state thing that you're changing. So that's what this error here means, is we are trying to mutate the state of our application. We need to be very explicit that that's something that we're trying to do. And the way that we can do that is just mark properties that you want to change as state. Then SwiftUI knows that that's something that's okay to change. The advantage of doing this is every time the state changes, SwiftUI will redraw your entire view. So once the selected index changes, the entire view is being redrawn. So now we should have these hooked up. So we can go ahead and click on this play button here. This is actually now running our simulator, just like it would be on an actual iPhone. And as we click on something, we see the color changing. And we see the color correctly matches what we expected to. Great, so far so good. So we've got some interactivity added in. We know that as we click on things, we can change that background color, and it's reflected that we only get to make one selection. Now, it's neat because it looks like, if you're not used to this kind of reactive style of coding here, that you're clicking on it and you're changing the background color by clicking on it. That's true, but it's in this interesting roundabout way where the color is just a function of the selected index. And if it's nil, it's nothing. If it's not the one we clicked on, it's clear. And if it is the one we clicked on, then it will be green or red, respectively, if it's right or wrong. Okay, so maybe one last thing that we want to do is, it's a little bit weird that you can kind of keep clicking and change your guess after you've made it. So maybe it'd be good to disable that so that once you've made a selection, that's your selection. So let's go ahead and actually add in that property. So we can mark that a button is disabled, and we can say it's going to be disabled if someone's actually gone and made a selection. So that's if the selected index is nil. And so now when we try to rerun it, is not equal to nil, excuse me. So we're saying once someone's made a selection, and the rapid prototyping is a great feature of this here, because you can actually see for a second everything was grayed out. Now when you click on something, everything else becomes locked. Because once the selected index isn't nil, once they've selected something, then we can't click on anything because all the buttons are disabled. Okay. Last bit of thing we can do with this is we can go ahead and add in some kind of next button that's going to queue us up for presenting something. There's a very easy way we can do that. We can go ahead and add in just simple if statement. We can say if the selected index isn't nil, Then we want to go and display a button that just says like next question or just next. Maybe a little padding around it. Okay. Buttons need that. And a question in chat, well, what if the index was 0? Would that work? Do you mean if the correct index was 0? Like if we swapped it so that moth was first and that was the correct index? So let's see.
Yeah,
if
sorry,
we
I was
swap it
just
so that,
asking, can you hear me?
Mhm.
I was just
Yeah,
asking,
go ahead.
if 0 is the index, like in JavaScript, that's like a weird, it's undefined or null. It's just weird in JavaScript. And it's not like that in Swift, I assume.
Nah, so Swift,
Yeah.
one advantage of Swift, so I've worked a bit with Swift and JavaScript. Swift is very precise and exact around how it works with content. So Swift is a type-safe language, which means a 0 is just a 0. It's never null, it's never nullish, it's never falsy, it's just 0. And so this selected index is an optional integer, which means it either contains a real number or it doesn't. So I totally get where you're coming from, because in JavaScript, like you'd say, hey, well, maybe 0 is like falsy or nillish or something. That's not how things work in Swift. Either you've got a value that's the expected type, or you don't and you just have nil.
Perfect. Yeah, you answered it. Appreciate
Perfect. And then Joey, you don't have to unwrap the optional. Good question. So when we're using the optional on line 45, in this line we are unwrapping it because we actually need to look and see what it is. Because we need to say, hey, is this selected index here? Is this the right index? Is this equal to the index of the actual button that was clicked on, that we're calculating the background color of? So we do have to unwrap it there. Here, we're not actually unwrapping it, we're just checking. Yeah. Exactly, yeah, and the guardlet. And then Josh has a good note. Yeah, you can compare optionals to non-optionals. You can map them, you can use flat maps. There's all sorts of fun stuff you can do with optionals. I'm not sure if that performance is always there. I started with Swift and Swift 2, we're on 5.5 now. They've added a lot of nice quality of life things where you can go and actually do like, you could compare a selected index. We might not need to unwrap it. It just makes the logic a little bit nicer here to make this case clear. So it's just best practice in general to be unwrapping optionals and doing explicit checks for that. Okay, great. So we want to add in that next button, which we have right here. And then let's go ahead and resume this. All right, and cool. So now when we click on something, we notice we changed the order, that's fine. We get this next button that shows up, but only after we click on something. So great. So we're basically set up with kind of a simple interactive view, and we're about to add a lot of organizational complexity. That won't add a ton of features, but it's going to set us up for building a really powerful application. One last step before that's just like a neat kind of high impact visual thing to highlight is we've got this really plain white background. A cool way we can mix that up is by just putting a color behind everything. One way we can do that is by using what's called a Z stack. So a Z stack is it's like a vertical stack lines things up kind of below each other. H stack or horizontal, put them next to each other. A Z stack puts them on top of each other. So what we can do is take all this good content here. One more. Then go and put it inside the Z stack. And then behind everything, we can add a color. So we can go and add in, say, what kind of color we want. One of these with a red of 7, a green of 0.7, and a blue of 0.5, and an opacity of 0.2. And so we get to see a color now is put just behind everything, which makes it nice to see. It's a little bit off. You can see here that there's kind of this white bleeding through here and here. This looks a little bit weird. Does anyone know why there might be this white bleeding through? Like, why doesn't the color just go all the way through? Safe area, Rails got it, Rails got it. Yeah, exactly. So the safe area is a concept in iPhones. You can see this is like a newer iPhone with a notch. What you have up in these corners on a real phone is you actually have the, like the time and your Wi-Fi signal and all other like sorts of good information up there. So being able, you have to explicitly say that you want something to ignore that, because it's a pretty bad user experience if text bleeds into that. So how do we set that up? Well, we can go ahead and look for modifiers. You can also look, as Josh has in the chat, and you can check for the safe area, and you can get to see that property show up here. So you'll note here, it actually picks the wrong thing by default. It goes with the Z stack because we were on it. And you can see why this is a good default, because this is all bleeding through the top. It doesn't know the notch isn't a real thing. No good. So we want to go ahead and change this into here. Joey's asking, how does this work with auto layout? So auto layout is the way that you used to lay out views, or you still do if you're using UIKit as a framework. The answer is that this is all weirdly hacked together auto layout that's happening behind the scenes. Occasionally, when you build something that you think is normal in SwiftUI, you'll see really weird messages in the compiler that some constraints are conflicting with each other. That's not great, but it's not really our problem. These are all happening behind the scenes. It uses auto layout, but we don't really need to worry about that at all in how we're building it. Okay. So we've got it set up right here. We've got our ignoring this. We are ignoring the safe area. Make sure to get rid of that placeholder. And yeah, Joey, that is exactly right. SwiftUI, you do not have to pin constraints, and I cannot stress enough for people that have not worked in SwiftUI and UIKit, that it is a pleasure to not have to worry about constraints. What we just built here, as I've been talking it out, when I used to teach, I would spend like a full 2 or 3 days just trying to motivate and explain how to make and position different UI elements. You just get great defaults in SwiftUI and enables you to build super quickly. Okay, so now we've got our color set up. We've got our, once we click on something, we see next come up, which is great, but our structure is a little bit awkward right now. So if you've been looking at this, you've been maybe a little skeptical of some of the stuff that's just kind of hard-coded in here. Like we have this question up at the top. It looks like really rigid. So we're going to take a step back and apply a lot of structure to our application right now, because we have a problem in that what happens when you click the next button? Like, should all of these be state and then we just rewrite them to different strings? Like, it's kind of a mess right now because we only have one view that's owning our state. What we really want to work towards is to build out a game model so that we can have a broader concept that dictates what question should be shown at the right time and make sure that we're capturing guesses here. Okay, so how can we go ahead and set that up? Well, first we're going to go ahead and build a question that's going to capture in some of these. So we're going to make a new file. We're going to make that as a question. Okay, question. And Josh in the chat has a great explanation of how some SwiftUI does placements. You can look into Geometry Reader as well if you want to go deeper into custom placements. And Joey, these are not using navigation controllers anymore. Maybe behind the scenes because all SwiftUI is kind of built on UIKit stuff, but there's a different kind of paradigm that you can use to be presenting. We'll see if we have time to get to that at the end. We're just going to be overwriting stuff here. It'll be fun. Okay, so what I'm going to do is I'm going to hold down the Alt key so I can put these up side by side. And we want to abstract some of this out into a question so that we can work on making our game that's going to own multiple different questions. So we're going to make our question here. Questions should have probably text. We need them to have possible answers, which is an array of strings, and we need them to have some kind of correct answer index. So this is all the information that we'd used before. So then we can go ahead and also maybe build out some kind of static property, like a class property, which we'll call all questions, which will just be a place where we're storing all the questions here, which is an array of questions. And then we'll go ahead and just put our questions here so we can go ahead and have somewhere to store them. And forgive me if I pronounce your name incorrectly, but someone has their hand raised up. That's Thedrin.
How you doing?
Pretty good.
What's the difference between let and status let?
Great question. So staticlet means that it's a class property, which means that it's accessible on, instead of an instance of a question, the concepts of the question itself. So an individual question has text, but the concept of question has this all questions property. In practice, it means that the way we're going to access this is by having something like question dot all questions. And that's not on any particular instance. It's on kind of the structure itself. A really common place that you see that is in like, let's say a double. Double is just a structure. You can make doubles, and then they have particular properties. Like you can go and encode them. You can check if they're equal to things, blah, blah, blah. But on the type double itself, you can access things like double.pi, which isn't true of any specific number. Like 2.pi doesn't make any sense, but the number pi is stored on the type double itself. Good question. So that's what that static is doing here. Cool. Okay, so putting in the rest of these possible answers, and now our correct answer index looks like it was 0. And then maybe let's just toss another question in just so that we can have it. Let's see, what language was used before Swift? So for any iOS people out there, what language would you code in before using Swift, and maybe still now, depending on the age of the apps that you're using? Maybe if you go back far enough. But yeah, Objective-C is the main one that I'd be using. Absolutely. I guess you could be using Smalltalk if you really go back far enough, but Objective-C, definitely the one that I'm more familiar with. And for you could, I think there was an Objective-C++ at some point, though, but
Yes.
we're going to go with Objective-C for this one here. Objective-C++?
Yeah.
Yeah. So that's not a framework I've worked in, but it is definitely a framework that I've heard of, at least. For a bit of a tangent, yeah, there's at one point there was a desire and kind of the intention of Objective-C that you could actually be writing code in straight C, and then occasionally be, because dipping down to lower level languages might be helpful. That's definitely fallen off as programming's evolved, and that sort of sentiment of maybe you need to write code directly in C isn't really something that the Swift team takes into heart, but it's a cool thing that you can do when you're working there. Okay, so we got a couple questions now, so we can go ahead and then, instead of these being kind of abstracted here, we can just make these into a single question, which is a little bit nicer here. So maybe like questions.all questions, and we'll just pick the first one. These go away, we've got our question. And then, as I do a lot, you build and you get to see what you've broken. And so these are all the places where we were depending on some question directly, and we can go ahead and take instead this question here instead of our hard-coded one. And then I think we called that something else. We called that correct answer index or something. Correct answer index. And then this is the question's question text. Something text. Something text. Bring it up. Just text. Okay. Great. All right, so now we've gone ahead and we've done our first bit of refactoring. So now it's a little bit cleaner. We just have this question instead of having a kind of bunch of hard-coded things. So it'll make it a little bit easier to work with. Now, we want to keep abstracting backwards a bit here. Now, instead of just having a single view and then a model which we're going to be reading and writing, which we're going to be reading from, we need something that's going to mediate between those. So to start with that, we're going to go ahead and put our game together, which is going to help us with our broad goal here of how do we get to see a new question and how do we keep track of questions that we've seen. So we're going to go ahead and build a new model here, which is going to be our game. Now, our game is going to be another structure, just like we had before. And our game is going to have all of the questions because our game needs to know how to transition from one question to another. So what we can do is we can go ahead and make that private so that no one else can see it. This is just a little neat thing you can do. You see this mini map, which is they've added to Xcode still recently in my mind. I guess it's been a year or two. But you can go ahead and put these pragma marks so that you can get to see content a little bit easier. So we can mark our private properties here. And then we can go ahead and see that pop up right there. And then we can go and add in our questions. And then here we can be using that type property, question.allQuestions, to go ahead and make sure that our game knows what questions it's going to be going through. Now it's going to be useful for this to also know what the current question is. So we'll go ahead and get it set up with a current question index, which will start at 0, reading from the first question. And we'll start with that for now. We'll build on that as we need to. So these are some private properties that are game house. So what we need to know now is we have to be able to get the current question from the game. So we'll go ahead and start there by having our current question, which is just going to give us whatever the current question is. So we go into our questions, we get the current question index. This here is a computed property. It's a little bit of a neat shorthand instead of making this a function. This is just, you can think of this as a function that doesn't take any inputs and returns a question. Okay, so we've got our question, and then we can start there. Okay, so now we've got our model. We're going to need to build it out a lot more. We've got, and I'll go ahead and bracket these two together and make a new group from these. These will be our models. We've got this content view, which maybe we should call this a game view. It's a neat thing you can do in SwiftUI. If you just right click on this, or in Xcode rather, go to rename. It kind of shoots down, shows you wherever you've used it, and then you can go ahead and call this whatever you want to. So we can call this a game view instead. This will go in our views directory here. And now in a kind of rapid fire introduction, the organizing concept between how architecture should be set up is that you have your views, which Swift helpfully names for you. You've got your models, which are just these structures which own information that's true, but you need some way to mediate between your models and your views. Your views shouldn't just change the models directly because you don't want to leak logic about what your game looks like into the model itself. This shouldn't know anything about UI kit. You should be allowed to use the same game for, a SwiftUI application or a UI kit application. It should just be a pure model that understands logic. So we need something that's able to mediate between them. In SwiftUI, the main architectural design is called MVVM, which is for model, view, and then view model, which mediates between them. So we're going to make another new class here. This one's going to be a class for a reason we'll get into in a sec. And this is going to be our game view model. Now, our game view model is going to have a lot of content that looks very similar to the game. We're going to be repeating ourselves a little bit, but the intention behind that is to make sure that we're setting up in a way where our view doesn't talk to our model directly, and our view model helps mediate that. As your apps get more complicated, you're building more and more, this kind of structure will make your apps a lot more resilient. So what do we want to do in our game view model? Well, let's build our game up. So we're not actually going to get an access to a game in our view. We're going to get a game view model. So anything that we'd want to know from the game, we need to be able to get from our game view model. Okay, and I'll set this up now. So one of the first things that we'll want to do is we're going to want to make our game view model an observable object. This means that as things change inside the game view model, it can publish those changes so that anyone that's observing it knows that it should redraw itself. Before, it was pretty easy. We only had one thing in here, just the selected index. When that changed, we redrew ourselves. That was it. Once we're being a little more complicated, more things might change about our game, and we want to redraw ourselves whenever that happens. So we're going to mark that the game is a published variable. And then anytime the game changes, those changes will be published, and anyone observing this observable object will go ahead and redraw itself. So that's a little bit kind of how the flow works with all of these different attributes in SwiftUI. This is one of the more common patterns that you'll use to set up view models and relate types to each other. Okay, so we've got our game view model here. We know that we have this, and we should probably have this as a private variable because we don't want our view to mess with this directly. So this is encapsulation or access control in Swift that we've been messing around a little bit with. The default level is internal, so I can say here, and internal just means that you're allowed to access it from anywhere inside the same module. You have to mark things as public if you want to be using it like across libraries or anything like that. But for the most part, internal and private will just help you build APIs that are more resilient so that you can be exposing only information that you want people to be messing with. Okay, so we've got our game view model. It's got our private game, but we need to expose the question into our view. So we'll go ahead and then we actually don't need to expose the whole question. We just need to expose the things about the question that the game view itself needs. And so that's a little distinction that can make it a little bit nicer, is that we don't have to have the view doing any of the work. It can just go ahead and say, hey, I need these things and I need my view model to give me the text for the question. But I don't necessarily care what the question is itself. I just need to be able to ask the right questions to the view model and get the answers I expect. So we can go and set up the question text, which is just going to be the game's current questions text. We're going to need those possible answer indices. So just kind of going through, I'm going to highlight them, going through each of the things that talk about questions and then delegating that responsibility to the game view model. Possible answer indices. It's going to be a range of integers is what that type is. And that's going to be the game's current questions, possible answers indices. And then there's going to be some other stuff we're going to want it to do, but we'll get to that in a second. So we've got the possible answer indices. Oh, right. We need to have the, let's see, what do we call that? Possible answer for index is going to go and tell us what the answer is for this index here. So this is going to be the game's current question, possible answers at whatever this index is. Okay, so it's a little bit of a kind of taste of how to work between your view model, and your model to show that you're not exposing everything. You're just taking the parts that you care about, that your view is going to care about, and exposing those to it. So it doesn't need to worry about those other elements. Okay, so what does all this mean? It means that we can go and add that in. There's a little bit of awkwardness that we'll have to fix in a second. As a state object, we can add in our view model, which is going to be a game view model. So this game view model is then owned by our game view. Could set it up differently, but this will work just fine. And so what we're going to do then is just replace all of those things that talk about the question with things that the view we're getting from the view model. And if we build it correctly, we should be safe in getting the information that we need. So let's go and just build so we get those red errors nice and helpful for us. This will be our view models.question text. This for each should also break. Great. So we can go instead and get the view model possible answer indices. And then here the text in the button should just be the possible and the view model dot possible answer for index. Okay, but it looks like there's one more place we use that question, and it's a little bit of a messy one. So we can see here, this actually necessitates a lot of changes to our model. because we needed to know what that correct answer index is. And well, I guess we could just have that be stored inside of our game view model, just tell us what the correct answer index is. I guess we could try that. Yeah, let's try that, fine. All right, so let's go and get the correct answer index. That'll just be an int here. And let's just get the correct answer index. All right, let's start with that. Okay. View model dot correct answer index. Okay. So far so good. Let me make this a little bit more visible. All right, so we've made a bunch of changes, but again, like I mentioned, these are mainly just going to be some smaller structural changes. They're not actually changing anything about how this looks. We've done our refactoring correct, then it has the same behavior as before. We're just reading our information from a different spot. Now, there's one more thing that we need to clean up. It's a little bit of an annoying one, but we're not actually doing anything to be tracking the selected index here, right? That's only owned by the view. And as soon as we, let's say, overwrote that with something else, we'd be destroying that information. That's not good. So we need to be making sure that we're taking this index and we're actually storing our information in the game itself. Because right now, we're just setting this property in the view, and we don't want to be storing our kind of meaningful state in the view, because that selected index is a really important part of how our game works. So we're going to go back into the game, and our game now needs a way to be storing these indices. We can model that a bunch of different ways. What I'm going to be taking a look at here is modeling it by having a, let's do it this way, yeah. We'll have a dictionary of selections. So dictionary or a hash map or an object, depending on what language you're coming from. And that's going to map a question to whatever selection was made by it. We'll get a brief compiler warning here because it doesn't know that questions can be keys in these kind of key value dictionaries. So we just need to go into the question and just say, hey, it's okay, this thing's hashable. And this shows you a lot of the cool stuff you can do in Swift as a language. Swift is a protocol-oriented language. So the way that you operate in Swift is you have a set of protocols or permissions about what things can do. So questions can do hashable because we've added that, that protocol to it. And that means that questions are now viable to have as the keys in dictionaries. The conformance for this we got for free because it's pretty easy to hash just a string and an array and an int. If we had a more complicated structure and we're adding hashable in, we might need to add our own hashing function or talk about what it meant to hash something. Bit of a sidebar, lots of fun stuff you can do with protocols. Okay, so we've got our selections. Then our game can have a mechanism for making a selection. So we can go ahead and make selection at index. And that's how we're going to actually expose an API for enabling a selection. Then that's just going to go ahead and take our selections for whatever the current question is and just assign it to that index. Note that because this is a structure, it expects that we're not immutable by default. So we need to just mark that this is mutable. And then it'll stop complaining. Okay, so our game knows how to make selections. Sherry, question? Protocol-oriented question. What is the protocol in this example? Great question. So in a protocol-oriented programming, the protocol is hashable. So if we kind of mouse over hashable and we take a look at what its definition is, we can see that it says here it is a public protocol. We can see that it has a bunch of good nonsense here about what conforming the hash protocol means, and then goes and tells us that a type that can be hashed into a hasher. So hashable is a protocol, and in this case, we're using it because we wanted to build a dictionary or a hash map or an object where the keys were questions and the values were integers. We couldn't do that by default because this is a little bit more complicated than just an integer or a string, but it's still not that complicated. So we just add the word hashable here, and it knows we can go ahead and then encode this question, or we can hash this question by doing whatever SwiftUI does, doing whatever Swift does automatically to combine these, which we're happy with because it's probably good enough for us. Good question. Yeah, definitely lots more in protocol-oriented programming. You can go super deep in there. And then hashable is a protocol because it dictates that's the best way to put it. In order to conform to hashable, you typically need to be implementing these things. You just happen to get a bunch of free conformance here, but you need to have a hash value and a hash. So normally you would need to implement this property and this function. You just get it for free. Cool. Okay, so we have our selection that we have here from our game, and then we can go ahead and take a look at how to add that into our view model. So our view model then also just wants to be able to make selections, because remember, a view can't talk to the game directly. It's got to go through the view model. So we can just go ahead and essentially build a wrapper around it. And then that'll set the selections, or we'll just tell the game to do whatever it does, rather. Okay, so then we have our setup here. So we know that we have a way to make a selection and have that get carried over to the game. Okay, so back in our game view, this is over here. So now, instead of setting the selected index, we can go ahead and just tell the view model to go ahead and make a selection at whatever index this is. Okay, so far so good. That works fine. That's going to carry over, but we're still using this selected index here. So we're going to have to take this code here and find a way to decouple it from this, because we really want to get rid of the stateful property that's storing important stuff inside of our game view, because we'd have to worry about writing it, and that's pretty annoying. So we want to go ahead then remove this selected index. This is going to then start yelling at us, because now we have a couple more things that we need to have information about. So we're going to have the game own these bits of information and then pass it on to the view model. And that's going to be a lot more resilient. So in our game, we're going to want to store information about if the selection was correct and what the selected index is, so that it can communicate that information onto the view model. So our game can know if a selection is correct by just checking if the selection that was made for the current question is in fact equal to the correct answer index. And we can set up a property to get the selected index by just reading from our dictionary. We could expose the whole dictionary, but in general, it's good to not expose information that you don't need to do, because then people might mess with it. Don't have to worry. Okay, so then we have our selected index right here that is now going to be owned by our game. So our game, because our game already had access to this information now that we're storing selections, so we really didn't want to keep it here anymore. Then we can go back into our view model over in here, and our view model can then go and figure out how to expose those properties that our game view will care about. View model, okay. So we want our game view model to be able to expose, let's see, that color for button, so that it's implemented in the right place. And we're also going to want to figure out how we can set that disabled status correctly. We can do that by just wrapping around that selection was made. So we have a selection was made, which is just if the game's selected index isn't nil. So we've just shifted that logic over. So now our view model knows if a selection was made. And notice here, this also reads a bit nicer, because now we can read from our, we're not abstracting this code, it's just living in the view model where we'd expect it to. Then we want to go ahead, this is the same thing. This is our view model selection was made. And then here we have our selected index. All of this code This is a little bit arguable if this code should be inside the view itself or the view model. I'm going to put in the view model, but I could absolutely see arguments for not putting it here. I'm generally okay if it's only a color that you're importing SwiftUI for, something minor. You could build a whole abstraction level around correct guesses and incorrect guesses, but that should be okay. So we're going to take this color for button, and we're actually going to move it into our view model. And then we just need to swap around the language a bit here to make sure that we're matching what our game can actually do. So this here is that a selection was made and that the index is equal to, that's game dot selected index, like so. And then here, if the selection was correct, which we just built in, then we can return. Okay. Great. And this is a view model method now. All right. So now let's go ahead and build. Build succeeded, always good. That's a lot of work we've been doing to have everything look the same if we've done it correctly. But let's go ahead and take a look. So we're previewing, we click on a thing. Great. Well, that was a lot of work to refactor, but it's going to make life a lot easier because we've built the whole structure we need to. And we can actually see that right now. When we reran it, this was pulled in a different question because we're using a game view model right now that shuffles questions because we set our game to shuffle those questions here. So when we're previewing, we actually get to see different languages pop up. And so that's a great way to ensure that the structure we built is pretty resilient. So as we select things, this still happens, great. We can then finally go to our next step of actually connecting the pieces here. So once we click on this next button, we've been holding out and saying nothing should happen. Well, we probably want something to happen. So we can go ahead and set that up by, what's going on here? Okay, by actually communicating to our view model that something should change. So we'll need to go ahead and build in that functionality right here. We just need to advance this current question index. So we're going to go ahead and make a function here that is mutating because it's going to change. We're going to call it advance game state. And that's just going to go ahead and take our current question index and increment it. And we'll do the same thing here. Advance game state. Okay, then in our view, instead of doing nothing, we can just call on the game to advance the game state. Game dot advance game state. Go ahead and resume. That's our view model rather. Go ahead and resume. Then when we run here, we get one of the questions showing up. We click. Then when we click on the next button, we get the next question. Great. So we've totally rewritten, our view here. We've recalculated everything, redrawn everything, because this property changed in our game. And because our view model is publishing all of those changes that happen, our view will redraw itself. So that's a nice, simple way we can have everything hooked up. Now, one last thing I want to do before we wrap here is we have almost built out the structure that we want for it. There's just one problem that you can probably see by the way we've implemented our game is we're just incrementing a number, the index each time. We're going to get to the end and we don't have any handling for that right now. When you click next, the second time, you just crash because we're out of bounds now. That's a pretty bad design. We wouldn't want this to just crash on our users. So we're going to need to add some handling to determine whether or not the game is over. So we're going to do that by just adding in a property called game is over. Lots of different ways we can implement this. This will be a bool. And we know that the game is over if we're out of bounds. So if the current question index is greater than the count -1, we're out of bounds. No good. Again, lots of different ways we can implement this. This will definitely work for here. And then we'll go and take our view model and we'll just have a wrapper around that. Game is over is just going to wrap our game dot game is over. Then back in our view, instead of trying to crash by reading all these things that are illegal to read, we can just say, hey, if the game's over, don't try to do any of this stuff. Just go ahead and display something that says game over. Otherwise, yeah, sure, go ahead and show everything. And this is something I like a lot about SwiftUI is you can just use if-else statements in your views, which is there's a bunch of weird nonsense that makes this work behind the scenes, but it's a very kind of cool way that you can be writing code pretty simply. So now, instead of crashing, if we've hooked everything up correctly, we get our 100%, and then we get to the screen, which is great, except now we're stuck because we just put a text here. So to unstick ourselves, this will be the last view we build here, since I know we're running a little bit up on time, we're going to put together a results view, which is going to just have a little bit of handling for what to do once the game is over. And because our views, we're looking a little sad with just one in it. So we're going to build a results view. And our results view is going to say that the game is over. And it would be great too if it could tell us how they did, what percent of questions you got right. We did all this work of tracking them, so we might as well build that into our game. So in our game, let's just grab how many questions were answered correctly. So we can grab the correct answer count, or I suppose selection to be consistent. And we can grab this by just iterating over each of the question and the selection in the selections dictionary, making some kind of count property. And then if the questions index matches the selection that they did, let's call this selected index matches. Scoping will get us there. If matches the selected index, then we'll go ahead and increment the count, and then we'll just return the count. You could also do this with higher ordered functions if you want to. Okay, so now we've got how many selections we made correct, and let's just grab the total number of questions. So the total question count, which is going to be I'm just going to call the selected I know I'm not going to run into issues, but just to be safe. All right, and then the total question count, which is just going to be the questions count. Then our view model can take those properties and then maybe expose some kind of percentage. So let's have our game over text. And this is just going to be some string that says like final score and includes the correct selection count times 100 over the total question count to get that as a percent. And now we have a game over text. So again, going through that, so you can see a little bit of the interplay between the building something out in the model and then having the view model read the parts that it needs so that our view can have the information to present. So we're going to need to have the view model here. And we're going to do that with one last trick, which is we can have an environment object. And what that means is that it's not owning it's not going to own or create a view model itself. It's going to have one passed to it. And so that's a very convenient way to pass kind of models or view models between different views in SwiftUI. Okay, so we can pass that as a game view model. Then we can have our text of the view models. What do we call that? Game over text. Like a big font title. And then the last thing we'll do is we'll go and add a VStack. And then in that VStack, we'll have the text. And we'll also just have a button that just says new game. And I'll go ahead and reset the game. It'll do that by going just into the view model. Just into the view model. We'll have a reset game. Reset game. And all it needs to do, view model reset, is just take this game here and just assign it to a new game. Because it's published, everything will rewrite and we'll be right back to the beginning of it. So we can take this game and we can just assign it to a new game. Okay, so let's go back to our game view. We can check out the preview in that other one as well. Let's go and resume. Okay, so we go ahead and we answer our first question. We answer then our second question. We click the next button. We see game over because we need to add in that we're actually transitioning to the results view. And we need to inject that environment object of the view model. And this is going to make sure that we're passing in the information we need to. Great. So then we see the final score. We see this new game button, which maybe we should push to the bottom. And when we click it, we reset right to a new game. So I'll just push that to the bottom. We've seen that. That's just a spacer. And that's some padding. Okay, great. So we saw a bunch of stuff here. This is making kind of a simple quiz app. We built the first view really quickly. We got to messing around with state. We saw some of the neat structures that you can use in SwiftUI, like for each. We then went through a really big refactor where we took all this individual view stateful stuff and we rebuilt our application as an MVVM application that had a proper model that owned lots of great information just about how the game itself is working, a view model that read from our model to communicate information that the view needed, and then also provided methods to communicate back to the game so that we can enable communication without polluting our model. So that's where I think where I'm going to stop for this right now for the app build out, but we got some time for questions if since we've seen some good ones in the chat, but I'm happy to take whatever questions people have. Hopefully you've enjoyed some introduction here to some stateful stuff with SwiftUI for building out something that's pretty cool.
Awesome, great job. I can't, really like say more than that because I'm kind of not a Swift person, but like I would say this is definitely really educating. And I definitely got a lot of value out of this particular meetup. So I'll go ahead and open it up to some questions from the group, especially at those who are more Swift inclined.
I'll read a couple first from chat. Is there an online course? There is one at Codecademy. Again, this is not like an official Codecademy thing here, but we do have some cool content on Codecademy for SwiftUI that I helped put together. So that's definitely someplace you could look at. What scope limitations does SwiftUI have compared with UIKit? It's a great question. I think the most obvious one is like photo access. For whatever reason, SwiftUI does not have any wrapper for accessing the camera right now. So you have to use UIKit if you want to do any camera stuff. That's kind of the specific answer. The general answer is that SwiftUI has a lot of magic that happens. It is a declarative language instead of an imperative one. So you just kind of say how you want things to work and it fills in the gaps. Sometimes it uses a little bit too much magic. And I've had weird bugs like a double transition is a common one when you're navigating. You're trying to present another view controller and it just like presents it and then puts it away really quickly and presents it again. There's really no information you have about why it's doing that. So you kind of need to start digging into lower frameworks to figure out what's going on. I see what syntax created the wrapper. You can use this @ symbol to create these property wrappers like state objects. There's a bunch of Apple tutorials as well on exactly what they get into. What's the difference between state object and observed object? That's a great question. Let's see if I can get this right. It's been a minute. Observed object, as we're looking here, we marked in our view model. Actually, hang on. What is the difference between state object and observed object? There's some difference between them, and I think it's a function of how things are updating. I know Josh has been sending some good ones here. I'll look that up and get back to you. I know there's a difference. If someone wants to put a link into it and Stack Overflow and get it to me, you can definitely feel free to. Thank you, Josh. State object is for an object you own. Observed object is for state that you borrow. That was a great way to describe that. Yeah, so state object here we're using because we are manipulating this game view model. We create it inside this game view. If we wanted to be using something that we were just using, just kind of borrowing state from somewhere else and not like making it ourselves, it would be an observable object. So that's kind of what we were doing here with our results view, how we had this environment object where we don't own this game view model, someone else is giving it to us, and then we're not creating it ourselves each time. Good question. If the backend to load games, save results, how do you split up the backend code? As a broad question, but a good one. I think it depends. Let's see. Load games, save results. I would probably use something like File Manager to just do it locally. That'd probably be the easiest. And then I would just build that into, I'd probably have a persistence model. And then the game might call some the game might have a persistence model that it owned as well. And whenever something important happened, like someone made a guess, it would call the persistence model to save the game and then load it again. That'd be a fun feature to build out too. Other questions? Stanford course is free. Yeah, Josh, I 100% recommend the Stanford course. That course is fantastic. The SwiftUI content that they have is fantastic. It goes fast and furious. Kind of how I first started to learn some Swift stuff. Paul Haggerty, I think, is the guy that does it. He is really, really smart, and I really recommend looking at the Stanford course stuff. It's super good. Let's see, is a spacer equivalent to constraints? Not quite. So I think Josh had a good summary up above of kind of 3 steps for layout process. So I'm just reading his stuff here, which is here, your parent proposes a size to the child to say like, hey, if let's say I am this view in our game view here, this body view, or on this Z stack, or on this V stack, and I'm proposing a size for how big the text to be. I do that first. The child then can select its own size, depending on how big it needs to be. And then the parent goes ahead and actually puts it in the context. So that's really how constraints are set out. There's a lot of negotiation that can happen there. And we saw a little bit of tweaking for how to make some of that size differently by setting frames directly. But there's no direct corollary to kind of constraints. So it's a very different paradigm for placing things. It's a lot easier if you want to get things that are good enough quickly. It's probably a little bit more difficult if you want to get things that are exactly to a particular specification. So I've loved it as a pedagogical tool, as a teaching tool, because I can make applications like this and only spend a little bit of time worrying about how things are placed and just kind of dump a couple spacers in. If you're working with auto layouts, you kind of need to either work in storyboard and kind of manually lay out a bunch of stuff, or do it programmatically, or use some kind of Cocopod that kind of makes the syntax nicer. But yeah, and then Ed's exactly right. There are geometry readers that can give you more information about how things are laid out. And so that is a geometry reader. I'll just take a look at it here. Gives you this like reader. And then this reader has a lot of great properties, like, you know, what is its actual frame in a particular coordinate space. So if you really want to build something totally customizable, you can just make a geometry reader, find out what space it occupies, and then you can do things by setting out frames manually. So you can do lots of customization with that if your UI demands it. If you're just trying to build something that's a bit simpler, you can probably avoid it, but that flexibility is there. I might have said Cocoapods, which is a dependency framework. How do you specify the specific X and Y coordinate positions of objects in a view controller? I would use a geometry reader for that. Yeah. So geometry reader is going to be the way that you can figure out where exactly things should be framed. And then I think things just have a frame property, and you can kind of like work and set things up where you want them to be. So in general, you should be setting things up kind of by using the spacer magic, but you can totally do geometry reader stuff if you want to. And yes, Josh is right. There's an offset property which you can use to go ahead and then just kind of move things around specific ways. So that's not going to say set it up at coordinate X and Y. It's going to be doing it within the already within the coordinate system that has been given. And that's what's that, the difference between frame and bounds, which is kind of always a fun iOS interview question. So the frame is kind of its universal position, and then its bounds is going to be relative to its parent. Unless I mix those up, and someone should tell me if I did. And as right, yeah, the most common way that you'll be wanting to kind of pad things is just with this padding property. And we saw that in a few different places. We've just been using the stock padding. If you look at the different initializers for padding, you can see that it takes in a bunch of different things. So you can specify a specific value you're padding around. You can have this edge inset, so you can have a different object that you're using to pad things. So there's a lot of flexibility. Aside from Codecademy, any other good SwiftUI resources? I'm gonna again echo, I think that was Josh's recommendation. The Stanford Course stuff is great and is free, so it's a lot of good content. Our stuff on Codecademy is good. I should like it, I wrote it, it's good stuff. That's great too if you are new to Swift as well, because we have a bunch of language content there that kind of teaches you a lot of what you saw previewed here. And then other good SwiftUI resources. I think Hacking with Swift is a good resource that you see. There's was it like Paul Hudson has some good Swift stuff. So there's lots of good stuff out there for sure. Ray Wunderlich obviously has tons of Swift content, so lots of good resources. These have been great. Other questions? Apps using MVC. Are MVC and MVVM essentially the same, or is there a difference? Great question. So I'll lead with a joke. MVC stands for Massive View Controller, stands for Model View Controller, but the joke being that when you're working in UIKit, your view controllers get really big because there's a huge amount of blurring between your views and your controllers. So yeah, I remember seeing some Objective-C, like, you know, MVC design view controllers that were like 1,500 lines long. So there's a lot of stuff that you can see in some of those view controllers. The big difference is that how I would describe it, MVC tries to make a separation between the model, the view, and the controller. In practice, the view and the controller become tightly coupled, because your view controller is responsible for laying out its views, but it also ends up doing a bunch of like talking to model stuff. So you really only have two pieces, your model and your view controllers, which also manage all of your views for you. What MVVM design does is it kind of intentionally says, well, that's just going to happen if you have that set up. So we're going to build in another layer, which is a view model, which is totally separate from those pieces, but acknowledges that, you know, there's going to be that step of communication. And then the view is just going to be as pure as possible. So it's going to be not mixed with MVC there. Yeah. So it's totally right. The logic should appear in different places for them. In general, the thing to emphasize is that your view should be really stupid. Like, and you never could get away with that in UIKit super well. Your views always were pretty tightly coupled to your view controllers. So needed to talk back and forth between them, and you have all this delegation and like target action stuff passing back and forth. In this here, I've tried to make a demo that has the view is as stupid as possible, and the view model really owns that level of communication. Yeah. What else? Someone's asking what I use for Swift documentation. I guess I just gone to the Apple documentation. I showed a little bit here. I just use the actual Xcode client sometimes if I want to take a quick look. Like if you just hold down Command and click on something, you can just go ahead and jump to the documentation in the client, which eventually loads. And then you can read about what's going on there. There you go. So that's probably how I look at kind of stuff, just if I don't really need to poke around. Otherwise, I'll just go and look at the documentation proper. Yeah, and that's with command click. Yes, question?
I see that Sherry raised her hand, but we didn't ask the question in the chat. Sherry, do you want to say your question or do you want to chat it?
Was that a mistake?
I think she chatted something to me directly, and I just read it out.
Okay, great.
Yeah, thank you though. Let's see, Joey's asking, and Josh is answering. Nice and easy. Do we still have collection views? Josh is right. Lazy V grid and lazy H grid do most of what you want to do before, and those are new-ish. I think those are last WWDC that those got introduced. I believe that's correct. But yeah, that does most of the work that you'd want to do with collection views. Yeah, and also just echoing Josh's second part, if you do want to be building your own totally customizable things, you can use UI view representable, and that's going to allow you to bridge between UI kit code and build your own view controllers, and then use them in a SwiftUI context. Swift documentation link is from Apple. Yeah, Apple owns Swift, so everything you find in Xcode is here. That's just Apple's documentation. You can also just go ahead and then just bring it up. Like if you just search for Apple, what do I call it, like for each SwiftUI or something. Like this is one of the most common ways to go and view something. Apple documentation is better at some things than other things. It has a little bit of a reputation of being extraordinarily perfunctory. Some of the SwiftUI stuff does actually include these snippets. Some of the older stuff you're going to be out of luck for. And then Apple itself has some tutorials up if you just want to have some like walkthrough guides. Yeah. Yep. Yes. Okay. Other questions? What are the big items that you don't get with SwiftUI that you do get in UIKit? Biggest one that comes for me is camera access. I think like there used to be more, but I think you have a lot of them now. I think you get maps now. Is that true? Yep, you get maps now. So they've been doing a good job about adding a lot of features to SwiftUI. I think that the biggest one is camera access, which you can't control, and anything that's going to be, I guess things that are dependency related is probably another good way to phrase it. Like if you're using a Cocopod for something and it hasn't been updated, then you're just going to have to use UIKit. And yeah, it looks like AV Foundation. I bet some of the like metal core graphics stuff, like core animation, if you're messing around with that, that probably you just have to dip into more UIKit stuff for. So generally, the deeper you're going to go into frameworks, the more you're going to find cruftier things. But yeah, as long as you're using UI view representable, you can build a SwiftUI application that has everything in it that you need, just like Josh was saying. You still might need to read and understand UIKit stuff, but you can wrap any of those view controllers.
All right, looks like we got through most of the chat here. So I guess at this point, if anybody has extra questions, what would be like the best way to get those questions over to you, Ben?
That is a great question. I wish I could say I'm active on Twitter. I do not really use Twitter. But if you have questions, I'll share a couple things here. I guess I'm going to share my LinkedIn profile just because you feel free to add me on that and ask something there. I check that. And then if you have any other questions, I'm putting my, I'll put that in the chat. And then if you have other things you're curious about, I just put my email in the chat. So if there's anything that you want to reach out on, you are welcome to. I will do my best to answer. I am mortal and flawed and whatnot, but feel free to reach out with questions you have. And it was a pleasure getting to present some of the stuff here. I will also follow up with you, Vijay, with code that we built out from this. So if anyone's curious about getting it afterwards, they can see exactly what we built out here. Something a little bit similar, but we did things a bit differently. And so I'll share that with you after.
Yeah, for sure. Yeah, you can send it to me directly. I'll make a connection with you right now on LinkedIn. So you can send it
Perfect.
to me there if you want. As well as, afterwards, we have a Discord that we use for people to, continue conversations, ask more questions there. So I'll put a link for that in the chat actually right now. And
Sounds good.
yeah. And just in general, right? Like, so we try to do meetups again once a month, maybe sometimes more than once a month. But the idea is to just kind of make, these meetup groups just more accessible, beyond just the scope of JavaScript. I think we wanted to start, also allowing people to, talk about software engineering and, things that might be interesting, sharing different repos, different stacks, different languages. So Swift is something that, I think that, some of our people in the group expressed an interest in. And so this is kind of nice to have that. I've just posted a link to the Discord here. And then I'm also going to post a link to my own LinkedIn for anybody who missed out on the beginning. Just put a link to me as well if you want to ask me questions, or if you want to connect and just say hi. I'm available for that. All in all, though, I think this has been a pretty great presentation. I definitely, like I said, I got a lot of value. I mean, I basically just done small tutorials with Swift on my own. I'm more of a web developer guy, but it was something that I wanted to set as a goal for myself, just start learning more native app development. And so I get the design patterns, the view model controller, that stuff is pretty fine to me. It's it makes a lot of sense. So just kind of sight reading what you're doing makes a lot of sense, but it's just kind of probably getting into the syntax. So I might do that a little bit later, So again, thank you for the tutorial. Pretty great. And thank you for all the resources as well.
Yeah, it was great to be here. I just put the code from today in chat if you want to go ahead and just take a look over at anything. That's all up on GitHub, so you can feel free to take a look. But it has been a pleasure to work with all today. Love the questions, and then help you build some cool stuff with Swift.
Yeah, thank you everyone again for coming. And again, if you have questions, you know how to find me. Be sure to look at the Zoom before I turn it off. But that said, we're on YouTube as well, and the Discord and all that, and javascriptla.net is your beginning point if you ever get confused about anything. All right, talk to you later, everyone. Have a great night. Thanks for coming.